Hey, hi, welcome back to the second part of our lesson today. I appreciate your continuing on with me. So I asked you to try example 2 yourself, and so here we are, hopefully just comparing your answers to mine. So here I have the setup. This is 1/2 r squared, and then d theta with the bounds as theta values. And it did say in the question from 0 to theta. I don't know why I am not able to pull this down. Again, the tablet, man, it's rough for me. I'm an old dog. All right, so here, did a little algebra. Here, use the identity for cosine squared, and remembering that there's that 1/2 in the front gives you the 4's on the bottom instead of the 2's, and I separated those as to two different terms just to make the integration piece a little bit more straightforward. And then at the bottom part here, you can see that I plugged in my bounds, simplified, and got 9 pi over 4. So if that's not what you got, do just pause and take a look at my writing and see if you can find your error. The part C of this said, how about if you go from 0 to 2 pi? Well, let's look back at our picture because we kind of haven't looked at the picture per se. We just went with what the question said as far as the bounds. But if you look at your graph or your calculator graph and play around with the bounds, like your window settings when you're in polar, and just go from 0 to pi, that's going to just give you the top portion of this graph. And so if you want to go 0 to 2 pi, that means you're including the bottom portion of the curve. And since there is symmetry between those two, you certainly can just use that symmetry to your advantage, okay? So by symmetry, I would say rather than changing the bounds, we could just say take 2 times our previous answer and get 9 pi over 2. That's how I would do that one. Okay? So again, if you have questions, I just hit the wrong button. If you have questions about this, feel free to email me. Hopefully it makes sense, all right? Let's go on for another one. Okay, the level of this question is pretty similar to the previous one. Again, it does tell us our bounds this time, so we're just going to set that up according to the bounds as they told us. So 0 to pi, and then I want 1/2 r squared d theta. Okay, I'm going to multiply this out. This time I need to use the identity for sine squared. So I'm going to have you work that yourself. If you don't know the identity, go back to those identities at the beginning that I pointed out and derive what you need for sine squared. And then I'd like you to come back to this video in a minute to see the rest. Okay, I know I'm asking you to pause and unpause a lot, but I feel like that simulates class better. So I hope that you're following along with me that way. Okay, so here's the writing popping up by magic. So again, just the green line is just using algebra, very similar to the previous question. The red line of writing, the first red line, is applying the, actually in the green writing, I also applied the trig identity. And in the red line is anti-differentiating and then plugging in those bounds. So we didn't really compare what the question was asking to the picture that we have here, but the bounds go from 0 to pi. So in this case, that would be going around the curve. It goes off my screen a little, and then over here. And so now if we were going from 0 to 2 pi, that would go back all the way around to the beginning of the curve, okay? You can tell this from looking at your calculator and watching how it graphs, setting different window settings. If you were to go through this and just change the pi, so like go back to this line of your writing and make that 2 pi and then evaluate the antiderivative, you end up getting 9 pi over 2. And so my follow-up question down here is, why doesn't this turn out the way the previous one did? Why isn't that just a doubling situation? So hopefully you can tell that in the picture, chopping it this way, it's not a symmetry situation, right? That's not 2 equal parts. So in the last part, I said, what should we do if we wanted to use symmetry? What could our bounds have been initially? So think about that for a second. How could we have cut this so that we would have 2 symmetric pieces, 2 equal pieces? Well, we would have cut it in this direction, right, to have symmetry. And so then your bounds would have been something like negative pi over 2 to pi over 2, or you could have done pi over 2 to 3 pi over 2, and then doubled. Okay, so that's just not a huge deal, a huge point of this, but something that is convenient in terms of just making your work go faster sometimes. Certain angles or antiderivatives might be a little more straightforward to deal with 0 and pi, for example, rather than 0 and 2 pi or something like that. I don't know. But just to have some flexibility and some options, and also to understand answer key solutions, because sometimes they'll use symmetry. All right, I'm going to end this chunk of the video here, and then we're going to have one more piece, I think. Yeah, I think just one more piece doing problems 4 and 5.